Hi guys, it's Mrs. Tucker. I'm going to talk about direct variation today in your textbook. That's lesson 5-5. I've made up my own PowerPoint on this one based on the placemat, some of the placemat problems that you guys did, because I think it makes it a little less confusing. So let's begin. All right, direct variation. Direct variation is just a special type of linear function. It has special features or special characteristics that other linear functions don't have. Do you want me to back that up? Okay, I'm going to pause it. All right, let me show you what I'm talking about. You guys remember Tucker's road trip? Okay, I'm going to use this one as my first example. And you guys have a copy of this in your journal. Take a look at the table here. And there's some things I want you to notice. You guys have learned that a slope is a constant rate of change, that it's the change in your y's divided by the change in your x's, which is really easy to figure out from this placemat, from the table. What is your slope here? 70, yeah. Your change in your y's is 70, your change in your x's is 1, so the slope is 70. There's something else I want you to notice. What do you get when you take that y of 70 and divide by 1? What's 70 divided by 1? What's 140 divided by 2? What's 210 divided by 3? What's 700 divided by 10? Each y in this table, when it's divided by its x, gives you a constant number. And that constant number is the same as what? Yeah, it's the same as your slope. Each y divided by its x gives you a constant number, and that constant number is the same as your slope. That's interesting. I want you to notice something else. Here's the equation. Do you see the form the equation took? Yep. Remember we just learned y equals mx plus b. What's your b in this situation right here? 0. Yeah, it's like adding on 0. But we don't normally write that. It drops off. Take a look at your graph here. This graph passes through what point? 0. A y-intercept of 0. That point right there is also known as the origin. So that's the next thing I wanted you to notice, that this graph passes through the origin, or that it has a y-intercept of 0. There's something else I want you guys to notice here. I've enlarged the table. And what happens when you take 1 times 140? What happens when you take 70 times 2? Ooh, that's freaky. What happens when you take 2 times 210? 420. What happens when you take 140 times 3? Ooh, that's weird. Okay, let's try this. Let's take these and try cross products. What's 1 times 420? 70 times 6? Whoa. Did you guys notice how all of the cross products in this table are equal? Yeah, that's weird, huh? Really weird. Cross products are equal with direct variation. And you guys, I've already pointed out how if you take this y and divide by this x, you get the same number as if you take this y and divide by that x. You can also see here that cross products are equal. Oh, that's weird. That's really weird. Okay, I've made up a new placemat problem that's not in your journal. Mrs. Tucker gains 3 pounds for each cheesecake she eats. Yum, yum. I love cheesecake. All right. Here's what I want you to notice on this one. What's the slope? Yeah, a change in y of 3 over change in x of 1. My slope is 3. What happens when you take this x and divide by that y? I'm sorry, that y divided by that x? You get 3. What about that y divided by that x? Yeah, they all turn out to be 3. Direct variation part 2. What happens when you take 9 divided by 3? 3. 12 divided by 4? Yeah, each individual y divided by its x gives you a constant number, and that constant number is the same as what? Your slope. Yeah. What do you notice about the graph? This is what Cameron was asking about earlier. What do you notice about the graph? Passes through the what? Passes through the origin. What's its y-intercept? 0, yeah. What do you notice about the equation? Yeah, the y-intercept is 0, that's right. And they usually don't put that on there. They drop that off. And from the table, are the cross products equal? And do you notice how I'm not using 0? What's 1 times 12?
12.
What's 3 times 4? 12. Okay, let's try this set. What's 2 times 9? 18. What's 6 times 3? 18. Yeah, cross products are equal. Yes, sir. Yeah, it would. That's like, I don't know. Cross products are equal. Shh. Here's one more from a few years back. You can tell how old this PowerPoint is. Locally, gasoline sells for $2.50 a gallon. So I put myself together a table. What's the slope in this table? Look at the change in your y's divided by the change in your x's. Yeah. Your slope is $2.50. What happens when you take this x and divide by this y? What do you get? 250, thank you. What happens when you take 5 and divide by 2? Yeah, what happens when you take 10 and divide by 4? Yeah, and that constant is the same as your slope. Look at your equation. What don't you see? Oops, you don't see it at all now. What don't you see down here? Yeah, the y-intercept, because the y-intercept's what? 0. Here's the table. What about cross products? They're always equal, that's right. All the data points in the table are equal. And you look at a graph and you can tell it's direct variation because it passes through what? The origin. Yeah, its y-intercept is 0. Okay? All 3 placemats have things in common. The first thing that they all have in common is that the graphs all pass through the origin. With direct variation, your graphs pass through the origin. Okay, that's the first characteristic. You have direct variation if all of the equations are in this form. Y equals kx, where k is a constant number. In the Holt book, it's called the constant of variation. If you look in the Glencoe book, my on-level book, they call it the constant of proportionality. All of these equations take on the same form. Y equals the slope times x. Your constant for each one of these just happens to be the same as your slope. Your constant of variation, what Holt calls constant of variation, what Glencoe calls constant of proportionality, it's going to be the same as your slope on your line. Here's another thing they all have in common. That constant of variation is the same number as the slope. Well, I just told you that. Direct variation part 3. Each ordered pair is proportional to the next. If you look at a table, you can tell whether it's proportional or whether it's direct variation by checking to see if data points in the table are proportional. Can you guys tell from the table that these graphs pass through the origin? How can you tell? Yeah, because 0, 0 is in your table, and 0, 0 is the coordinates of your origin. Yeah. Is the following placemat like the 3 previous? Remember growing trees?
No. It didn't pass through the origin.
Does not pass through the origin. Down here in your equation, what's your slope? Let me rewrite this. Y equals 2 plus x. What's your slope? No, that's the y-intercept. What's the coefficient of your x term? It's not 0. It's 1. So what's your slope here? It's 1. It's the coefficient of x. Here the line does not pass through the origin. Your y-intercept is 2. Here are the data. Here we're going to calculate the slope, and we already pointed that out. Your slope is 1. What is 3 divided by 1? 3. What's 4 divided by 2? What's, let me find an easier one to do. What is, none of the rest of them are easy. 12 divided by 10 reduces to 6 over 5. Is it the same as these numbers here? No. Do you have a constant of proportionality here? No, not like we did with direct variation. Yeah, we're not getting the same numbers when we take each y and divide by each x. Take a look at this equation. What do you see in the equation that we didn't see with direct variation? Yeah, a y-intercept other than 0. The equation's not in this form, y equals kx. Are the ordered pairs proportional? Let's pick this one and this one. What's 1 times 5?
5.
What's 3 times 3?
6 or 9.
Yeah, cross products aren't equal here. Direct variation is just a special type of linear function. It has special features or characteristics that other linear functions don't have. The graph passes through the origin. Your y-intercept is 0. You have a constant of variation. K is also equal to the slope, and your data points are all proportional. The end. Now you know everything I know about direct variation. Yeah, let me close out this video, and I will go back. You guys are welcome to rewatch this video on YouTube. Good luck with this.